Welcome to New House Practical Science. I'm Dr Woodroffe. Today I'm going to talk to you about elements. We're doing more about elements, and in this section, in this lesson, you're going to be able to, at the end, name 3 magnetic materials, name only the metal and only non-metal that are liquid at room temperature, and identify an unknown element from its physical and chemical properties. Okay, so you can see I've got a few elements gathered around me. I've got a whole array. All of these elements are listed in a periodic table, all right? All the names, the symbols are listed in a periodic table. And in your textbook, there is a picture of a periodic table. I also have a periodic table picture here, which I can show you there. All right, and we are going to look at the properties of some of these elements, all right? And from those properties, we're going to group them into whether they are metals or non-metals, all right? So the first thing we're going to do is we're going to use a magnet, all right, to look at these elements. So I'll start off with one, all right? Here's my magnet, all right? And I'm going to use this first element. This is iron. All right, we've got an iron nail. I'll pop it on the bottom there. You can see that the magnet attracts the iron. All right, the magnetic field attracts the iron. I'll pop that there. Here we have a sheet of copper, and we have some pieces of copper. Okay, so here's our copper. Here's our copper. The magnet is the same there. You can see, so copper isn't magnetic. Okay, let's try it with aluminium. Here's our aluminium. Again, the aluminium is not magnetic. All right, we'll do one more of these. Here we have zinc. Take our piece of zinc out. You can see the zinc is not magnetic either. Okay, we'll do this with, this is sulfur. Now you might have seen me do this in the previous video with sulfur, nice yellow substance. And I put the magnet in the jar, and you can see, if you look at the jar, you can see none of it is being attracted to the magnet. All right, so from that, you can deduce that, all right, most elements are not magnetic. In fact, there are only 3 elements that are magnetic. Iron is one of them, all right? The other 2 are nickel and cobalt. Okay, I haven't got any nickel or cobalt here, but iron, nickel and cobalt are the only magnetic elements. And you'll notice that they are metals, all right? All non-metals are not magnetic. Right, the next little thing we're going to look at is we're going to look at a property of metals and non-metals that and how we can separate them into groups. We're going to look at how well they conduct electricity. And to do this, I've got a circuit here. I've assembled a circuit. I'll test my circuit. You can see that when I close the circuit, the light will go on. All right, so it's a fairly simple experiment. All I'm going to do is put my test material between the 2 crocodile clips, all right? So you might want to make a prediction for this, all right? You might want to predict which of the elements that I've got along here, which of those will conduct electricity and which ones won't conduct electricity. Right, so here we go. So we'll start with iron, because it's the closest to me. You can see, touch that together. Oh dear, let's have a look. That would be a bit embarrassing. So you can see that goes on. So the light goes on when I have iron being tested. All right, iron is a metal. We'll try copper. Now, you'd expect this. This is copper wire, so it's used for passing electricity. All right, there you go. So our copper wire conducts electricity as you'd expect. We'll take our zinc. Here's our zinc. You can see our zinc, our sheets of zinc conduct electricity. Next one we'll take, I've got my sulfur, so I'm going to pop some of the sulfur into the lid here. Oh, big lump of it has just landed there, and I'll put the. Alright, you can see that the sulfur, when I touch the crocodile clips at either end of this big lump of sulfur, you can see the light doesn't go on. Okay, so that's my sulfur. We will do some calcium. Now, take the lid off my calcium. Here's our calcium. These are little granules. All right, move them over there, and I'll choose one granule. And they've got a calcium oxide layer, so you can see the oxide layer is preventing any conduction, but as calcium is a metal, it would conduct electricity. Okay. Next piece I will take is some aluminium. Okay. Here's my aluminium. And you can see the aluminium conducts electricity there. I'll go over to this side. Okay, so here we have nitrogen, our gas. Right now, I'm going to have to do this quickly. So what I'll do is I'm going to do it upside down so the nitrogen doesn't escape. I'm going to put one in. All right, there you go. One goes there and one goes there. And you can see, oh, my light fell over. Oh, and there goes my nitrogen. It didn't conduct the electricity. And you find the same for the oxygen and the helium. Potassium, sodium and lithium, I'll show you those in a second. I'm not going to do those because they are actually stored in oil. And the last one we'll look at here on this side is our bromine. Let's have a look. And you can see if I dip it in, it doesn't conduct the electricity. So, from this, all right, we can group our elements, all right? We can group them into elements that conduct electricity and elements that don't conduct electricity. And as you will have deduced from this, the metals all conduct electricity or are good conductors of electricity. The non-metals are not good conductors of electricity, okay? And the same also applies to conducting heat. Metals are very good conductors of heat, and non-metals are not good conductors of heat, okay? Now, the next thing we'll look at is their appearance. So, the most obvious one we'll start with is our copper. So here we have our pieces. We have a sheet of copper here. So you can see, here's our copper. Now, it's been polished. You can see that the copper is shiny, all right? If we go along here, oopsie, we go along here, we have our aluminium sheet. You can see that that is also shiny. Okay, and let's have a look further along. Zinc, so slightly different colour, but again, a nice shiny element. Okie dokie, and have we got any more there? So the metals, aluminium, magnesium, copper, zinc, iron. Now the iron here is shiny, it's a little bit rusty, so it's corroded a bit, but it is still shiny, all right? So all of our metals, all right, that you've seen so far are shiny. Now I'll show you some other ones. Now we have, this one is lithium. All right, I'll put my glasses on for this because it's a bit nasty, or can be. So lithium is stored in oil because it's so reactive. But lithium is a metal, and you can see it doesn't look shiny at the moment, all right? But if I cut it, okay, I'm going to cut it in the top here. It's hard to cut. This one. Oh, the piece is quite big. So I'll just cut it a bit, and I will expose the edge. All right, and you can see that around the edge that I've just cut, you can see the lithium is shiny there, all right? And the lithium, because it's reactive, all right, it forms an oxide layer, so it takes the shine away. But if I expose the lithium straight away to air, you can see it's shiny. So the lithium, although it doesn't look shiny, is actually shiny, all right? So there's our lithium. Potassium is the same. I'll just show you the potassium. We've got some very big lumps of potassium here. Again, potassium being so reactive, it's stored in oil. All right, so here's our potassium. It doesn't look shiny at the moment, all right, but if I cut it, you'll see the shine showing that it's a metal. So the metals are all shiny, so their appearance, they all have this shiny appearance, all right? You know, all everyday objects with metals like this spatula, which is made of iron, the tongs are made of iron, they're all shiny, the scissors, the scalpels made of iron, the crocodile clips I have here made of iron, so they're all shiny. Whereas if you look at our non-metals, you can see our sulfur, it's a yellow powder, it's quite dull, it's not shiny. And if you look at these non-metals, all right, we've got nitrogen and oxygen gas. Again, you can't see the gases, so they don't have a shiny appearance. Our helium gas doesn't have a shiny appearance, okay? And obviously our bromine water we have here, which is bromine that's been diluted. Again, the appearance is not shiny, it's a liquid, so you can see. So the other property of our that we're looking at appearance, you can see the pattern is that metals are shiny, non-metals are dull, okay? Two more things I'm going to look at. So we have what we call malleability or malleable, and that means can you bend it? So the obvious one to look at here is we have our copper, and you can see our copper, all right, copper sheet, nice and bendy. Take a hammer to it, bend it into any shape that we like. All right, so malleability or malleable is a property of metals, all right, and also ductile. Ductile means you can draw your element, your metal, into wires, and you can see here's our copper, and it's been made into this nice wire we have here. Okay, and so I'll show you now a periodic table. So on a periodic table, it has all the elements listed. Here's one that has the element symbols only, and you can see, if you look at the periodic table, you can see that all the metals are generally on the left-hand side of the periodic table. All the non-metals, the green ones you can see on this one, are on the right-hand side. So the metals are red on the left-hand side, the non-metals are green on the right-hand side. And in the middle, we have these, what we call metalloids, which are like, they've got properties of both metals and non-metals. Okay, I hope that's enabled you to name the three magnetic elements, to name the only metal and non-metal that are liquid at room temperature. In fact, I've told you one, there's one there. The other one we have in thermometers. It's a metal, begins with the letter M. I'll let you guess that. And how you could identify an unknown element from doing an experiment like this, how you can use their chemical and physical properties. Okay, I hope you've enjoyed the video, and I look forward to seeing you soon. Bye now.